Welcome back to the solutions manual. In this video, we will solve the problem F4-10 from RC Hibbeler Engineering Statics 14th edition. According to this problem, we have to determine the moment of the force F about the point O, and we have to express the result as a Cartesian vector. So to solve this problem, first of all, we have to determine the coordinates. So the coordinates of point O are 0, 0, 0 meters. The coordinates of point A are it's 0 in the x-axis, 3 in the y-axis, and 0 in the z-axis. And the coordinates of point B are it's 4 in the x-axis, 0 in the y-axis, and 0 in the z-axis. So now we have to express this force F in terms of Cartesian vector form. So force F is its magnitude times its direction, and for the direction we can use the unit vector along the line of action of force. So the unit vector AB will represent the direction of the force F. Let's call this equation 1. Now for the unit vector AB, we have to do the position vector RAB over its magnitude, and the position vector RAB is the coordinates of point B minus the coordinates of point A. So we have 4i minus 3j plus 0k divided by its magnitude. So we have 4 square plus minus 3 square. Upon simplification, the unit vector AB comes out to be 0.8i minus 0.6j plus 0k. So this is our unit vector AB. Now we have to substitute this unit vector into the equation 1. So our equation 1 becomes the magnitude of the force F is 500 newtons. So 500 into the unit vector AB, which is 0.8i minus 0.6j plus 0k. So upon simplification, the force F in terms of Cartesian vector form becomes 400i minus 300j plus 0k. Now for the moment of the force F in terms of Cartesian vector form, the moment vector is the cross product of the position vector ROB into the force vector. The position vector ROB is this vector. So now we have to find the position vector ROB. So the position vector ROB is basically the coordinates of point B minus the coordinates of point O. So we have 4i plus 0j plus 0k. So to solve for the moment vector, we have to use the determinant of a 3 by 3 matrix. So we have I, j, and k, and then we have the position vector ROB. So it's 4, 0, and 0, and then we have the force vector F. So it's 400i minus 300j plus 0k. So expanding by raw 1, the moment vector m can be written as I. So when we do the expansion by the raw one, we have to ignore these elements and we have to consider only these ones. So we have 0, 0, negative 300 into 0 minus j. Now we have to ignore these elements and we only have to consider 4 and 400 and 0 and 0. So 4, 400, 0, 0 plus k. We have to ignore these elements and we only have to consider these 4. So we have 4, 400, 0 minus 300. So now it's a determinant of a 2 by 2 matrix. So if I have a 2 by 2 determinant of elements A, B, C, D, then we can write it as A into D minus B into C. So similarly, we have I, 0 into 0 is 0. So 0 minus 0 into negative 300 is also 0. Minus j, 4 into 0 is 0. Minus 0 into 400 is also 0. Plus k, 4 into negative 300 is negative 1200. Minus 0 into 400 is also 0. So upon simplification, the moment vector m in terms of Cartesian vector form comes out to be 0i plus 0j minus 1200k. So this is our final answer. So this is it for this problem. I hope you would find this video helpful. If you do, please make sure to subscribe to this channel and also turn on the bell icon for the daily updates. And if you have any questions or any doubts in the determinant of a 3 by 3 matrix, then feel free to ask in the comment section and I will try to answer them as soon as possible. Thank you.